Right, good morning, grade 11s. We're going to talk today about restrictions on identities. Okay, restrictions on trig identities. Let's just call them identities. Okay, now before I even go to the restrictions on identities, you know that an identity, you should know this by now, is an identity is identity, okay, is a statement in which the left-hand side is equal to the right-hand side, okay, for all values. For all values. Okay, except we're going to stick in something now. And we're going to put that in a little bracket, except when an identity is not defined or undefined. All right. Now, when have you ever heard of restrictions? Okay. I sincerely hope that you remember from grade 8. Okay, but I always call the 11th commandment, thou shalt not divide by 0. Thou shalt not divide by 0. Okay, so if you're dealing with a fraction, okay, so if you're dealing with a fraction of any sort, okay, your denominator is not allowed to be equal to 0. Okay, there are two other ones that are just as important. Okay, the other big one in trig that we need to know is we need to know that whenever we're dealing with the tan of theta, the tan of theta has asymptotes, agreed? So we know that theta is not allowed to equal 90 degrees or 270 degrees. Okay, all right. Now, before we even start with restrictions, there are a couple of things that I think are vital that you know. Okay, number one, so let's just say vital pre-knowledge. Vital pre-knowledge. All right. Number one, you need to know that the tan of theta you could rewrite as the sine of theta over the cos of theta. You need to know that sine squared theta plus cos squared theta is equal to 1, and then derived from that, you can say therefore sine squared theta is equal to 1 minus cos squared theta, okay, or you could say cos squared theta is equal to 1 minus sine squared theta. Those you need to know absolutely off by heart, okay? The other thing that I think is also important is that you know the basic shapes of all your graphs, okay? So if I asked you to draw y is equal to sine theta, okay, we're just going to draw it roughly, okay, it's not going to be perfect. There it goes. We know that our sine graph has that sort of a shape, okay? We know that's at 0, that's at 180, and that is at 360, that's 270, and minus 1, and up here we've got 90 and 1. Okay. Y is equal to the cos of theta. Okay, again, just a very simple little graph. Okay, and I'll explain to you just now why they're important to know. Okay, here we know we've got 0 and 1. Here we've got 90 and 0. Here we've got 180 and minus 1. Here we've got 270 and 0. And over here we've got 360 and 1. Okay. And then y is equal to the tan of theta. Okay, remember when we're dealing with a tan graph, I'm going to start, and I'm just going to draw a complete graph from my asymptotes. So I'm going to start here at minus 90. Okay, and I'm going to go up here just to 90, just to give us a full graph. And then my graph is going to look something like that. Okay, remember at 45, it is equal to 1. At minus 45, it is equal to negative 1, and it's not there. And if it carried on here, it would go through to 180 and naught, okay? All right, and so it would continue, okay? Right, now, once we know that, let's now start looking at identity. Okay, for example, let's take example number 1. Example number 1, I give you 1 plus 2 sine x times cos of x all over sine x plus cos of x, and I tell you that it's equal to 1. Okay, now this is a trig identity. I know in this identity that my left-hand side is equal to my right-hand side, but I notice that it is a fraction. And if it's a fraction, I've got to be very careful because my denominator is not allowed to be equal to naught. My denominator is not allowed to be equal to 0. So what I do is I say, therefore, I let it equal 0. I get sine of x plus cos of x, and I say let it equal 0. Okay, I'm going to rewrite this. Sine of x is equal to negative cos of x. Ooh, sines and coses, I know if I divide them, I'm going to get to tans. So divided by cos of x, divided by cos of x, and I get that the tan of x is equal to negative 1. So when tan is equal to negative 1, this identity will not work. Now, if I go to my basic graph and I look over there, I can see that x is going to be equal to negative 45 degrees. Again, I'm going to keep this as a general solution because they didn't give me a restriction. Remember with the tan graph, we always add 180k, where k is an element of integers. So whenever x is equal to negative 45 degrees, or plus or minus 180, this identity will not be true. Okay. Right, example number 2. And the question says, state the restrictions on. State the restrictions. State the restrictions on 1 plus sine theta all over the cos of theta, which is equal to the cos of theta all over 1 minus sine theta. All right, first thing I look for, are there any tans? Nope, I don't have to worry. But I know that I've got fractions. And if I've got fractions, I therefore know that the cos of theta is not allowed to equal naught, so I'm going to let it equal naught. And I know that 1 minus the sine of theta is also not allowed to equal naught, so I'm going to let it equal naught. Now, if I know my graphs properly, and I go back up to my cos graph, I can see quite clearly on my cos graph, where is cos equal to? 0 at 90 or 270. So if I come back here, I can say theta is not allowed to be 90 degrees plus 360k, where k is an element of integers, or theta is not allowed to be equal to 270 degrees plus 360k, when k is an element of integers. Okay, on this side here, I'm going to go 1 is equal to sine theta. All right, go back up to my sine graph. Where's my sine graph equal to 1? My sine graph's equal to 1 at 90 and 270, which is exactly the same as what I've already got, so I don't have to rewrite it. Those are going to be my restrictions. Okay. All right, let's go on to example number 3. All right, example number 3. The question says 1 minus the cos of theta minus the cos of theta times the tan squared of theta all over 1 is equal to the cos of theta. All right. Now, again, I have a denominator. I've got a fraction. So I'm going to let the cos of theta be equal to 0. Now I'm going to steal from the one above that. I know straight away that theta is not allowed to be 90 degrees. And I'm actually going to say here where theta is an element of 0 degrees to 360 degrees. Sorry, I shouldn't have done that first one. Let me just erase that. Erase. What am I doing? All right, where theta, what is it doing now? Okay, where theta is an element. Okay, so it's not allowed to be equal to 90 degrees, nor is theta allowed to be equal to 270 degrees. Okay, but in this here I've got tan. Okay, so remember, as soon as I've got tan, what do I know about tan? Tan is not allowed to be equal to 90 degrees or 270 degrees, which I've already got written there. Okay, all right. Okay, and that really is how easy it is. Okay, let's do one more together. Okay, let's do example number 4. Sorry, this yellow paper runs out after a while. Example number 4. 1 minus sine theta all over the cos of theta is equal to the cos of theta all over 1 plus sine theta. It is an identity, and I want to know for which values, if theta is an element of 0 degrees to 360 degrees, this identity will not be valid for. All right, so it's not going to be valid when my denominator is equal to 0. And I know, and I can steal from above because I know this already, and I can look on my graph, theta is not allowed to be 270, and it's not allowed to be 90. Here, I'm going to go sine of theta is equal to -1. If I go back and I look at my sine graph, I will see that theta is not allowed to be equal to 270 degrees. Just watch the wording of these questions. So they want to know for which values is theta equal or not equal. So if they said for which values is it undefined, you would say when theta is 90 and 270, you wouldn't have the not equal to. Okay. All right, just be careful of that. All right, and then let's do one more. I'm trying to see if we must prove one. Actually, no. Let's just leave it at that. Okay. So basically, when you're dealing with restrictions, all you have to do is be careful that your denominators are not allowed to equal 0. And remember, if you've got a tan, 90 and 270.